So, good morning, everyone. This is Mike at the Manufacturers Association. We're putting this webinar on with Doosan Robotics of America and Industrial Automation Solution. Today, we have Stephanie Calloway and Jesse Hidalgo from Doosan presenting. I know some of you have met Stephanie at our golf tournament. And then we have Mark Chapman on the call from IAS, who you've also met at some of our events last year at the Manufacturers Summit that we hosted in May.
How's Megan?
Mark and IAS were there with
It's been one of those.
were there with one of the Doosan robots set up as kind of a palletizer. So some of you have seen some of this before and have had a bit of an introduction, and some of you this will be brand new. So I'll let Stephanie take it away.
Okay, awesome. Thank you so much, Mike. Thank you. Hello, everybody. Nice to see everyone here. And those of you that I've met before, nice to see you again. So welcome to today's webinar. This is going to be the first in our three-part series, which is Understanding Cobots, the Basics, and the Benefits. So a little bit of background on this webinar. This is meant to be a very high-level introduction to collaborative robots. The next two in our series will be a little bit more granular as far as real-world applications and a little bit more nitty-gritty. So to kick it off, sorry, I'm juggling a screen and a script and all of this, so bear with me. I'm Stephanie Calloway, and I work with Doosan Robotics to help businesses across North America implement collaborative automation solutions. And I'm excited to be joined today by Jesse Hidalgo, who's one of our talented application engineers at Doosan Robotics. Jesse has extensive experience working with cobots in a variety of industries. He's going to be much more your in-the-weeds engineer, nitty-gritty detail type guy. He's got experience with manufacturing and logistics to food and beverage and beyond. So throughout this session, we'll share insights into what cobots are, how they differ from traditional automation, and the many ways they're transforming workplaces. Also, as a side note, I'm getting over a cold, so if I have to break and sneeze or cough, I apologize in advance. But before we dive in, I also want to take a moment to thank the Manufacturers Association of Maine for giving us the opportunity and a platform to share this information about collaborative robotics with everyone attending today, because organizations like Maine play a crucial role in fostering innovation and supporting growth in the region, and we appreciate their efforts and the opportunity to speak with everyone here today. So I also want to highlight an important local resource for you in New England. Like Mike mentioned, Industrial Automation Supply, they're based out of Portland. They're a fantastic distributor for Doosan Robotics. In fact, they're #1 in North America for Doosan Robotics distribution. And they're a valuable local partner for all of your automation needs and businesses looking to explore cobot solutions. So I've also had the privilege of visiting Maine. I've met a few of you. I've been there several times over the years during my time with Doosan. And each time I tour a new manufacturing location or a business with IAS, I'm impressed by the drive and the innovation of the people I meet. What you guys are doing up there is truly impressive. Maine's manufacturing community demonstrates a really strong commitment to not only adopting cutting edge tools and processes to drive growth, but also to protecting the environment and their workforce. So although Doosan Robotics Americas is based in Dallas, Texas, and it may feel like Maine today because it's 14 degrees outside, we want to make sure that we are clear that we're supporting you guys in New England. We recently partnered with the University of Maine's Advanced Manufacturing Center to establish an offsite training facility, the first in the United States for us. They're going to provide hands-on experience with collaborative robots to businesses and students in the region. And this partnership is part of our broader mission to make automation more accessible and help manufacturers integrate technology in a way that benefits their workforce and operations. So with all of that being said, let's get started. So this is a quick look at our agenda today. The topics that we're going to cover, we'll first define what collaborative robots or cobots actually are and how they differ from traditional industrial robots. And then next we'll explore benefits they bring to manufacturing, from increased productivity to addressing workforce challenges. And then we'll go over some of the key features that make cobots unique, including their built-in safety and ease of use. And then finally, we'll take a look and do some real-world applications where cobots are making a difference in different industries. Again, this will be a very high-level view. We really encourage you to join us for the next parts in this series in 2 weeks to see some in-depth video. So at the end of this session, we will also have a live Q&A, so please feel free to drop your questions in the chat as we go along, and we'll address as many as we can during the instance. And then if we don't get to your questions during this webinar, we will follow up after the fact with our answers. So we're really excited to go through this with you guys, and let's go. So what exactly is a collaborative robot or a cobot? A collaborative robot or a cobot is designed to work safely alongside humans in shared workspaces. Unlike traditional robots, which are big, heavy machines that operate behind safety cages like you see on the image to the left, cobots are built to interact with people directly, like you see on the image at the right, which is a welding application. So they're engineered with advanced sensors, force-limiting technology, and intelligent programming, which allows them to detect when a person is nearby or in contact with them, making them significantly safer to use. Instead of replacing workers, cobots are designed to enhance human capabilities and supplement the workforce by taking over repetitive, physically demanding, or precision-based tasks. A lot of times you'll hear people refer to those as dirty, dull, and dangerous. One of the key advantages of cobots is that they're highly adaptable. While traditional robots require specialized programming and a dedicated team of engineers to operate, cobots are designed to be intuitive and user-friendly, meaning that even employees without extensive technical backgrounds can quickly learn to program and operate them. I always like to use myself as a little bit of an example here. By day, I'm in marketing, but we have a really great solution that's a palletizing solution, and I learned how to program that in less than 5 minutes. So I always like to say, if I can do it, most people can do it. So I made a little timeline for you here that shows the history of cobots. You can see starting back in 1996, the term was first coined. Cobots have been around for a few decades, but their adoption has surged in recent years. The first cobots were introduced in the mid-1990s, but they were fairly limited in capability. So over time, advancements in sensors, software, and most recently AI have made cobots more intelligent, safer, and easier to deploy. Today, we're seeing cobots being used across a wide range of industries, from small machine shops to large-scale manufacturing facilities, thanks to their flexibility and affordability. The demand for cobots continues to grow as companies look for ways to automate without the high costs and complexity of traditional robots. And also, as we accelerate through this AI revolution, we do think you're going to see a little bit more of a democratization of programming for collaborative robotics. Jesse will kind of touch on that a little bit later on with Dart Store and some of the things that we're doing there. So what's the difference between cobots and traditional automation? This table kind of lines out the bigger differences, but when you're considering automation, many manufacturers wonder whether to invest in collaborative robots or traditional robots. So let's take a look at the key differences that I've lined out here. Traditional industrial robots are powerful and highly efficient, but require safety fencing and specialized programming. So think super fast, super heavy, super precise. This makes them ideal for high volume production, but less flexible for manufacturers who need to handle frequent changes in production. They also often require complex programming and a dedicated team to maintain them. Cobots, on the other hand, are designed to be inherently safe, meaning they can work alongside humans without the need for cages or barriers. They're also much easier to program. Many can be set up and deployed in just a few hours compared to days or weeks for a traditional robot. So this makes them a great fit for small to mid-sized manufacturers looking for cost-effective automation solutions. There's also no maintenance required with cobots, so you're not having to grease joints and things like that every few hours. I like to talk about this in regards to consider somebody with, a seasonal line, a manufacturer with a seasonal line, like a candy manufacturer that, creates a Valentine's hearts or something like that. Collaborative robots are perfect for an environment like that, where the box size is changing, the pallet size is changing, the pick and place and the product size is changing constantly. A cobot can be brought in, deployed to deal with that seasonal line, and then move to the next seasonal line with very little, upset to the facilities. Whereas an industrial robot is, drilled to the floor. It requires somebody who has a specialized knowledge of the programming, et cetera, et cetera. So let's talk about one of the biggest advantages of cobots, which is increased productivity. Because cobots can work continuously without fatigue, they can take over repetitive or labor-intensive tasks, allowing human workers to focus more on complex and valuable activities, more fulfilling activities. This leads to improved efficiency, overall product output, and employee retention. For example, in machine tending applications like the one in this video, a cobot can load and unload parts into a CNC machine 24/7 with minimal supervision. This not only reduces downtime, but also helps manufacturers maximize their existing equipment. This ability to run lights out operations where machines continue working even outside of normal business hours can significantly improve return on investment for companies looking to scale their production. And with that, I'm going to toss it over to Jesse to talk about what makes cobots flexible and adaptable.
Hello, everyone. I'll start off by talking about some high-level things and then get a little technical. So first, we see a Doosan Robotics lineup of cobots. So what I'd like to capture here, though, are what are the capabilities of a cobot. Oftentimes, I meet people that have a perception that they're like toys or that they're for hobbyists, mainly because they're familiar with industrial robots or other types of automation. So what I'd like to point out is that cobots mean business. They have a reach from 1 meter up to 2 meters, and their payloads vary from around the 5 kilogram range to the 30 kilogram range. And they're meant for all different types of environments. Here, I'm in my office environment, and this is somewhere in the middle. And for reference, I'm 6'2", and this is a 10 kilogram robot. So it fits on a tabletop, but there's also robots that fully extended are about my height. And recently, the trend is not to just have cobots in office and traditional manufacturing environments, but there's also been cobots that are meant for to be safer in food environments, in environments that maybe expose the robot to moisture, and also even explosion-proof environments. Can you go to the next slide, please? So for those that have never seen a cobot, I'd like to show a visual aid of what exactly you can expect when you go to a cobot manufacturer and you're considering a cobot. So, and this is relative to the industrial robot. You may have a perception of they're much larger and their controllers are much larger. So you'll receive a cobot, of course, and you'll receive two other things. First is the teach pendant, which is like the tablet or command center, and the control box, which is about the size of a desktop computer, and that is the brains of the robot. So you'll have also usually access to an offline programming software, and this will require your own laptop, but this is where you'll be able to do offline programming and simulations. And lastly, for cobots, you generally need to only have power of 120 volts. So the same types of plugs that you have in your home or under your desk at the office. And could you go to the next slide, please? For the purposes of this discussion, I'd like to highlight that what we consider a collaborative application, and this is usually the time when a cobot is most advantageous, is when the robot is able to have power to its motors or servos on, and there is a program running on the robot controller, and the robot is in automatic mode, meaning that someone is not controlling the robot in the background. So let's talk about so Stephanie talked about a little bit about the comparison between the industrial robot and a cobot. So I'm going to continue on with that theme and talk about what makes the cobot flexible and talk about how it's cost effective. So first, industrial robots are heavy compared to cobots, which would be considered lightweight. An industrial robot with the same payload is heavier than a cobot. As a concrete example, an industrial robot with a payload of 20 kilograms weighs around 200 kilos. And I'm sorry if I'm using kilograms instead of pounds, but this is generally the metric or the unit of measurement that's used when you're discussing robotics. And a collaborative robot with the same payload of 20 kilograms weighs just about 70 kilos. So for reference, our heaviest cobot, which is one that is about my size if it's fully extended, is usually moved with 2 people, and the smallest robot can be moved by 1 person. This lightweight also contributes to the fact that cobots only require 120 volts. For reference, most industrial robots require some kind of industrial power, like 3-phase or 200 volts plus. Secondly, an industrial robot is usually fixed and fenced, meaning that the base or the robot itself is attached to something like your concrete or the floor of your facility. However, with a cobot, due to its inherent safety design, which I'll touch on a little bit later, you have the ability to place a solution on a cart-style setup or on some other mobile platform or AMR. An example of cost effectiveness due to mobility is a manufacturer of metal parts, which has several CNC machines in their shop, could be able to tend with a mobile cobot solution a machine in the morning and a different machine in the afternoon. If you try to do the same with an industrial robot, you'd either require 2 robots required to move the machines closer together, or have one large robot that can tend both machines. The third feature is how beginner-friendly cobots are relative to the industrial robot. For this portion, most industrial robots use some kind of proprietary language, but most cobots on the market are using something open source. So our robots, for example, use Python. And what this what this means for cost savings is the time and money saved when you consider the training for the programmer or yourself, and having quicker proof of concepts and being able to have fast changeover of parts. When you introduce new parts into your facility, you're going to be able to change your program much easier. And the last thing is, with a traditional robot, you don't have the ability to safely stop when they are in contact with a human. But when you're working alongside humans, with the cobots, you're able to do this usually in the wild in a fenceless environment. For cost, this means that you're going to save on fencing, safety hardware like light curtains, and the man hours spent to manage the controls of like your safety hardware and working on the PLC. Secondly, for most manufacturers, floor space is very expensive, and fence solutions occupy more space on the production floor. So can you move to the next slide, please? Now let's talk a little bit about safety. So most of you that have done automation before may be wondering, what are the standards that govern safety for collaborative applications? So this slide is worth a screenshot. So many times when a customer is new to cobots, they have to discuss with their health and safety department about implementation. So where can you begin? Well, there are 2 standards that you should reference. The first one is ISO 10218 Part 1 and 2, and the second one is the technical specification 15066. The first one is meant for the manufacturer, and the second one, 10218 Part 2, is meant more for the person that's going to install the robot or the integration of the robot. And the U.S. adoption of these standards is listed below, the RIA R15.0620.12. And one important highlight to take away from these before we move on is that, in essence, even if you have a collaborative robot, it doesn't make up your full system. So when you use a collaborative robot, you always need a risk assessment. And that means that you need to consider where the robot is going to be applied. So what is its environment? What is it doing? Even though the robot is safe, if you were to take an extreme scenario where someone puts something sharp on the cobot, well, then you could risk harming an operator. So then that wouldn't be a collaborative application. So let's move on to the next slide. So this is going to be a little bit more technical. So as I mentioned earlier, the reason that you're able to use a collaborative robot around humans while humans are in the operating space of the robot is 2 reasons. The first one is from a physical standpoint, these robots do look sleek and sexy, but the reason that they're sleek is they're meant to not have any pinch points. If you look at most industrial robots, they have their motors on the outside and they have sharp things. So if you were to come in contact with someone with some robot that had the design, you would likely hurt the human or potentially puncture the body. And secondly is due to the specifications and the standards. So In ISO 10218 Part 1, it states that a collaborative operation of a robot is allowed if the robot has power and force limiting by inherent design. In layman's terms, the robot has the ability to come to a stop when it senses a collision with a human or with its environment. In order for the robot to come to a stop, it must be able to detect a force, right? So there are two different types of technologies on the chart on the left. So the first one on the right-hand side is current control, and it is the most basic. It indirectly measures torque by drawing a correlation to the amount of current at each motor. And so a spike in the current of the motor is correlated to a force, and then the robot comes to a stop. And this is considered the most basic technology, and it's not sensitive. And it's not the most sensitive. The second mechanism by which you can have a cobot detect collisions is via joint torque sensors in every axis. The sensors directly measure the torque generated at each of the robot's joints, and this is considered the most sensitive technology on the market currently. This technology enables the robot to apply forces and also to act as a spring as it's moving, as it's processing contours on parts. I'll touch on those features in the second part of the series when we're talking about successful applications. The forces with which the robot is allowed to come in contact with a human are outlined in the ISO technical specification 15066, which I showed on the previous slide. Although it is not a standard, it contains guidance on how to conduct a risk assessment and what the acceptable forces are for a robot to come in contact with a human. So they're different based on what areas of the body the robot comes in contact with. So based on your risk assessment, you could define your force and torque limits and speed limits in the safety configurations of your robot. So this is all things that contribute to safety. The other features that are available to you when you use a collaborative robot are safety rated monitored speed, which allows you to set your TCP speed, so how fast the end of your robot is moving. And it also allows you to set different force, torque, and speed thresholds when you're inside of different zones. So, as an example, if you never want your robot if your robot is placed on a table, like when I was moving my laptop around, and you never wanted the robot to go through the table, then you'd be able to configure a zone where the robot can only stay inside of this cube on your tablet. And then even if a programmer called the robot and asked it to go directly through the table, then the robot would automatically come to a stop. Could you move to the next slide? So now let's cover ease of use. Some of the features that make a collaborative robot easy to use, and there are two. Cobots come with a teach pendant, which I mentioned earlier in the box, and this can be thought of similar to an iPad. It hosts an intuitive user interface with navigation similar to a website. The simplest way to program cobots is via block programming. Here, it's referenced in the bullet points as drag and drop. Each block is representative of a function such as a movement, a signal turning on and off, or a logic statement. The teach pendant is also where you configure all of your safety settings, and you also have an emergency stop button. Secondly, direct teaching, or the ability to put your hands on the robot and move it around. Most cobot manufacturers allow you to do this by pressing a button on the teach pendant. On the Doosan robot, you have the exclusive cockpit, which is a set of buttons on the flange, and you're able to move the robot around with your hands, and then save those positions into those same blocks that are representative of a movement on your tablet, allowing for faster proof of concept and programming. So I just want to show that quickly. So if this is the robot, I place my hand on the robot and I can move it around. And I'm doing this with one hand, so even though it's a light, but then I can take those positions and save them. And that is, I'd like to make a distinction that it's usually not possible to do that with an industrial robot unless you have some kind of third-party peripheral. Can you move on to the next slide, please? So far, I've been talking a lot about the cobot itself and safety. But if we consider the cobot in the real world, it isn't alone in its environment. So it is part of a solution. In fact, you wouldn't be able to do much with just the cobot itself. When I was moving the robot around, you may have noticed that it had something at the end of it. We usually refer to this as end of arm tooling. in the picture it's shown in the image on the PowerPoint is shown as a claw. And the other types of the gripper that I have on this robot is a vacuum gripper. There are claw style grippers, and there's also cameras and screwdriving tools. And I'll talk more about the different types of end of arm tooling in the second part of the series. So this is an important part of your system, right? Your cobot, your end of arm tooling. And the next part of your system is, what is your workpiece? So the object that you will be moving around, manipulating, or inspecting is also important to consider as part of your system. And lastly is its environment. So what are its surroundings? Is it on the cart? Is it fixed to the floor? Or is it on something else like an AMR or some 7th axis rail? All these things combined, shown on the screen, make up your solution or application. And this is where you have 3 different choices. Alone, you can create your system and be responsible for the solution and be responsible for the risk assessment and the programming. Or you can consider that you could work together with someone like a local distributor, like IAS, which will provide you with training, guidance, and support. But also not just with the cobot, but on what peripherals you can choose. And if it gets too advanced, then this is where you look to a solution provider or a system integrator, which your distributor can introduce you to. And there are also pre-boxed solutions, both from the hardware standpoint and from the software-based solution. So on the left-hand side, we see a little smartphone. And a trend that's starting to happen in cobots is, as I mentioned, the tablet is similar to a website. And so these cobot manufacturers, including ourselves, are building platforms that resemble websites. And this means that they're also enabling developers to create applications where everything is hosted directly on your controller, and it's very easy to use. So it removes all of the need for knowledge of programming, and most of these apps are very like GUI, drag and drop, picture based. All right, so now that we understand what is in a cobot solution or what needs to be considered as part of your application, what can be considered part of your application, let's talk about some industry examples. All right, so here, let's talk about some cobots in the wild, and we have 3 different examples. So these are 3 of the most common examples, and in the next series, like I said, I'll talk about a lot more. So the first one is palletizing. So if any of you have been on LinkedIn, then you've probably seen a bunch of cobot palletizing and depalletizing applications. With a cobotic palletizing robot, you can expect a robot to reach speeds of about 10 to 11 boxes per minute. But what makes these applications popular is these solutions are usually programming free. So from their HMI, which we can see there, you usually have some kind of drag and drop where you're able to build your pallet pattern and move boxes on the screen. And then the robot handles all of that in the background, and you don't have to do anything. It's very easy to do. And even Stephanie has mentioned that she's done it before, and she's not an engineer. So for this type of application, you're usually looking at larger robots due to the reach to be able to reach all extents of the pallet. And for reference, these usually require a robot that has a payload of 20 kilograms or higher. The second application is welding. So this is popular among high mix, low volume operations. And they're usually teaching the pathing via hand guiding. So this is an area where using a cobot is using a cobot's design or one of its features comes in handy. So they usually drag and drop the robot to different parts of the different places on the part to program the weld instead of having to do it from the controller or having to use a 3D CAD model and doing some kind of offline simulation. So the result is usually a high quality, repeatable weld, and you also have different weaving patterns that are available to you from the robot side. And here you usually see robots in the 10 to 20 kilogram range, but again, the range is important because it allows you to have a larger workspace and be able to clamp different size parts to your workspace, to your work table. And the third most common application, I'd say, is machine tending or some type of tending. So CNC machine parts are usually placed in an array on a table next to the robot, and the robot feeds unfinished parts and removes finished parts from the machine and either drops them back off in another array or drops them off in a bin. And these applications are usually standardized as well. The only thing that kind of changes for this is for palletizing and welding, you usually have consistent end of arm tooling for all your parts or for all of your packages. But for machine tending, you may require different end of arm tooling, and that's when a tool changer comes in, and I'll talk about that in the second series as well for different parts. Now, could you move on to the next slide, please? So I mentioned 3 of the top applications, which if you just go on YouTube or LinkedIn, you'll see those most commonly. But here are some more applications. So some are similar to tending, so moving parts, but there are also some applications that are very, I guess, beginner friendly, like inspection. So I won't go over all of these applications. I'll let you read them or take a screenshot. But I'd just like to say that in the next series, the way that we're going to structure it is I'll talk about some of the most common peripheral devices used with the cobots, such as like the tool changer, which end of arm toolings are commonly used, and which other peripherals like related to safety that allow your robot to go max speed and then human safe speed when a human's in the workspace. And then also we'll structure it as which applications are considered easy, which applications are usually require a system integrator or more advanced user, and which ones are already prepackaged and commonly found on the market that require no programming or hardware experience from the end user. Stephanie?
Great. So we have a spot for questions if there are any questions that we can answer. There's a Q&A box up at the top, or you can just drop it in the chat if you like.
Yeah, well, we're waiting for any more questions to come in. I actually do have one. In Maine, we have probably 1,900 manufacturers, and a lot of them skew smaller. I think about 1,800 of those are less than 20 employees. Are there instances where a company might just be too small for this to make sense?
No, I can handle this.
For-
As an example, I've seen this guy who's just running CNC machine shops in his garage, and it's just him and his wife. And I guess they were alternating, feeding the parts to the machine with each other. Like she would help him while he's at work. And then he ended up putting a cobot in his garage, which was mobile. He had 2 machines that were kind of at a 90, and he would move his cobot based on which machine he couldn't tend that afternoon, instead of having his wife supporting him. So I don't think that it's about a small operation. It's if you have the need where either you need to move your workforce somewhere else, or if demand is increasing and some people have trouble with hiring, so that they need to move their workforce to somewhere else, and they could offload something that's I guess not as uh, technical to a robot.
And I will say too, to kind of piggyback on that, some of the instances that I've seen, um, I think we really need to rework what we think of as ROI, in that what's the value for you to have assistance like Jesse's mentioning, especially in small operations, the value to have the assistance there that is consistently showing up and not starving lines or starving productivity or things like that. So, I mean, of course, there's investment piece to it, but in the long term, I think that you avoid a lot of overturn and a lot of unnecessary onboarding of employees that maybe aren't sticking around for these jobs like Jesse's mentioning, with loading and unloading a CNC machine, or deburring or polishing, things that don't necessarily require a super specific skill set. They just require arms. But sometimes those arms are the hardest thing to keep there in the environment. So
Excellent. That sounds good. And then, with the programming, I know you say it's relatively easy. Is that something that the distributors are able to help with too? If I roll one of these into the plant, I'm probably not going to figure it out right out of the box.
No, yeah. So a market comment to this, but most distributors have demo units where they offer to roll them into your shop and show you how easy it is, or even just show you like, hey, this robot's capable, and show you how to make a basic program. I think I could get someone to make a basic program if I just have the block program and show them how to manipulate from the flange within probably 15 to 30 minutes, just movement. Right now, when you're talking about setting signals on off and maybe if you have communication to a machine, like something you'll need with a CNC, then of course that requires a little bit more time and experience. But I would say within half hour, you could at least get the robot to move, and especially if you're using the drag and drop drag feature or direct teaching feature.
And we do have resources. Obviously, you know, like Jesse mentioned, Industrial Automation Supply, there is a huge resource as far as programming assistance goes. We also offer training here in Dallas. And then with our new partnership with the University of Maine, there will be training offered at UMaine Orono as well, on Doosan robots. So there's an opportunity in several ways to learn if there's a desire to learn how to program those robots. So.
Excellent. Well, I'm not seeing any other questions come in. We do have this recorded. It will be posted and distributed some way after this. I haven't decided that yet. The next part of the webinar will be on March 6th. This same team meetings link will work, but I will also redistribute that probably a day or two before the event as well, so you've got it fresh in your inbox. But if anybody doesn't have any more questions, I think that covers it for today.
Great. We thank you guys so much. Mike and the MAME team, thank you guys again for allowing us to just kind of let everybody know what cobots are and how they can and shouldn't be used. So we look forward to hopefully seeing you guys in 2 weeks to talk more in depth about use cases and success stories.
Excellent. Thank you very much for hosting, and we will see you on March 6th.